Unit 1, Video Lecture 4.2. This is a supplement to the metric conversions video lecture. I basically forgot to throw on some derived units there for you, and I wanted to make sure that we went over them with you. When we talk about a derived unit, we can talk about something like meters per second. What we'll be dealing with a lot and very often is grams per mole, or something like dollars per hour. The key thing to remember is that these slashes, this per in meters per second, in grams per mole, and this dollars per hour means to divide. So per means to divide. If we saw something like 15.0 meters per second, we can write that by saying 15.0 meters over 1 second. If we consider our grams per mole, let's say if I told you that nitrogen has a molar mass, of 28.02 grams per mole, well, the ways that we can write that relationship are 28.02 grams per 1 mole. And since it's a relationship, we can write it the other way, just like we can do all conversion factors in all relationships. So if we look back at our 15.0 meters per second, we can write that as two conversion factors, saying that we have 15.0 meters in 1 second, or in 1 second we can cover 15.0 meters. So let's look at an example problem. The average speed of a car is 35 kilometers per hour. How long will it take the car to travel 500 kilometers? 500 kilometers is what we start with. So it will go in the upper left-hand corner of our conversion table. Now, 35 kilometers per hour. 35 kilometers per hour. Remember, this per means to divide, so we can set up this relationship as 35 kilometers over 1 hour, or in 1 hour, we can travel 35 kilometers. Which conversion factor am I going to use depends on what I want to cancel. This conversion factor has kilometers on the bottom and hours on top. So 1 hour on top, 35 kilometers on the bottom. We set this up so that whatever we want, in this case speed, will be on the top of our conversion table. So 500 times 1 divided by 35 equal to 14.3 hours. Let's look at an example that deals a little bit more with chemistry. The molar mass of hydrogen is 2.02 grams per mole. How many moles would be present in 10.3 grams of hydrogen? So we're starting with that 10.3 grams of hydrogen, and we'll put that in our upper left-hand corner. Again, we have 2.02 grams per mole. That slash means to divide, so we can say 2.02 grams over 1 mole, or 1 mole over 2.02 grams. In this case, we want our grams to cancel, so we'll put 2.02 grams on the bottom and 1 mole on top. Grams cancels out, leaving us with mole, which is the unit we want. So 10.3 times 1 divided by 2.02, we have 5.10 moles of hydrogen. Let's take a look at one more. The molar mass of water is 18.02 grams per mole. How many grams of water would be present in 3.6 moles of water? 3.6 moles is our given, so we'll put that in our left-hand corner. And now 18.02 grams per mole. we write that conversion factor as 18.02 grams over 1 mole, or 1 mole over 18.02 grams. In this case, I want moles to cancel, so I'm going to use my first conversion factor. 1 mole on the bottom, 18.02 grams on the top. Moles cancels, so 3.6 times 18.02 is 64.9 grams of water. Remember when you're doing this that the mole is the SI unit for the amount of a substance. It's very synonymous with a dozen. Remember, when we say something like kilometers per hour, when we write that conversion factor, it's always 1 hour. If we say grams per mole, it'll be some number of grams over 1 mole. Whenever we say per something, it means per 1 mole. Hope this helps. Good luck.